Assalamualaikum students. Today we will start the third variant of the paper 2, October number 2025. So we will be doing the selective questions of the chapters which we are currently covering. So we have question number 9 first. In question 9, which compound has an empirical formula that is the same as its molecular formula? So we need to convert all these formulas into their respective structures, and then from those structures we will find the molecular formula, and at the last we will find the empirical formula. So about the butane, you are familiar that we represent butane as CH3 single bond CH2 and then CH2 and then CH3. This is the structural formula of butane. We now find the molecular formula from this structure. That means it will be C4 and H10. C4H10 is a molecular formula. Now determine the empirical formula of this molecular formula. You need to count. You just need to find the simplest ratio of the atoms. So we can see if we divide 4 by 2 and 10 divided by 2, you will get C2H5. C2H5 is the empirical formula of this butane. So they are different. C4H10 is different than the C2H5, so this is not its empiric. They are not same. Empirical and molecular formulae are not same. Then the next part, which is B. In B, we have but1ene. So for this purpose, for this case, you will again need to draw its structure. Ene means it's an alkene, and position 1 indicates a double bond between carbon 1 and carbon 2. So between carbon 1 and carbon 2 is double bond, and then it continues with the single bonds. Now complete all the hydrogens. The terminal carbon of this side will have 2 hydrogen atoms, and then this carbon will have 1 hydrogen atom. This carbon will have 2 hydrogen atoms, and this carbon will have 3 hydrogen atoms. Now determine its molecular formula. So its molecular formula will come out to be C4H8. This is the molecular formula, and then determine its empirical formula. It's simple, just divide both atoms by 4. So it will be equal to CH2. So empirical formula and molecular formula are not same. And then C option, butanoic acid. So it's again of 4 carbon atoms. So its structure formula will be CH3, CH2, CH2, and then COOH. Now its empirical formula, sorry, its molecular formula. Its molecular formula will be C4 and then count the hydrogen atoms. 3 plus 2, 5, plus 2, 7, and then eight, one more, 8, H8, and 2 oxygen atoms, so O2. Now its empirical formula, divide all the atoms with 2. So you will get C2H4O. Now they are different. Molecular formula and empirical formula are different. And at the last, butane 1O, that means 4 carbon atoms, and with any one of the terminal carbon, just connect the OH, which is a functional group of the alcohol, and complete the rest of the carbon with the hydrogen atoms, so CH2, 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 and then CH3. Now determine the molecular formula. It will be C4, and then add the hydrogen atoms, 3 plus 2, 5, then 7 plus 9, and then 10. C4, H10, and 1 oxygen atom, O. So in this way, this is the molecular formula, and at the same time, it's also the empirical formula, because you cannot divide, you cannot further simplify it because it's already simplified with 1 oxygen atom. So this is both molecular formula and empirical formula. In this way, the correct option becomes D option. So D is the correct option. Then our question number 10, next question. Which row identifies the charge on the chromium ion and on the sulfate ion in Cr2O4, Cr2SO4 whole thrice? Now, you're supposed to find the oxidation states or just the charges on chromium and sulfate. If we split this formula into its respective parts, it will become, you are already familiar with the construction of the formula. That means the charges are basically crisscross to make the formula. Like if I have A and B with these charges, they are crossed in this way, and they will make formula like A3 and A3 and B2. In a similar way, just split this compound into its respective parts. So it will be Cr. Cr will carry this 3 as a positive charge because Cr is chromium, which is a metal. And sulfate will be sulfate ion. So sulfate is SO4, and this 2 will become its charge. So it will be SO4 minus 2. So in this way, you have determined the states of the charges of the chromium and sulfate. So it is minus 2 from sulfate part and plus 3 from the chromium part. Plus 3 and minus 2. So the correct option becomes C. Then question number 11. Which statement describe, this is not included in our relevant chapter, so we skip this question 11. We're moving to the next question, question number 12. Calcium carbonate decomposes when heated strongly. CaCO3 decomposes into calcium oxide plus carbon dioxide. How many gaseous molecules are produced when this much gram of calcium carbonate is completely decomposed? Now here we need to do some calculation because this question is related to the stoichiometry. First of all, convert this much mass of calcium carbonate into the moles. We know moles is calculated by the formula mass over mR. So number of moles of the CaCO3 is equal to its mass divided by its mR. The mass is already given, which is 10 gram, but we need mR. So mR of the calcium carbonate is determined from the periodic table. Calcium mass is 40, carbon mass is 12, and oxygen mass is 16. So there are 3 atoms, 16 times 3. This will be equivalent to 100. Now determine mole. So 10 over 100, that is equivalent to 0.1. So we have 0.1 mole of calcium carbonate. They are asking about how many gaseous molecules. The gaseous molecule on the product side, that is on the carbon dioxide. We need to find the molecules of carbon dioxide, and for that purpose we relate the Avogadro's number with that of the mole. As we know, 1 mole is equal to Avogadro's number, 1 mole, and value of Avogadro's number is 6.02 into 10 raised to power 23. This is equivalent to 1 mole. And in our previous calculation, we got 0.1 mole. Now, we have to find how much moles will that be for carbon dioxide if we are given 0.1 mole. It's simple, just do the ratio method, which is simple. Calcium carbonate ratio carbon dioxide. So if we have 1 mole of calcium carbonate, so that is also 1 mole of carbon dioxide. That means if there is 0.1 mole of calcium carbonate, it is equivalent to 0.1 mole of carbon dioxide. So both are same, 0.1 mole of each. Now 0.1 mole of carbon dioxide is calculated in this way. Now convert that value into the number of molecules. So 0.1 multiplied by Avogadro's number. 6.02 into 10 to the power 23. So it will be equivalent to 6.02 into 10 to the power 22. So in this way, C is the correct option. Then further, question number 13. Which product is initially obtained at each electrode during the electrolysis of concentrated aqueous sodium chloride? Now, for this purpose, you need to go to the literature and find the topic of the electrolysis of aqueous concentrated NaCl solution. We had discussed already in the lecture, there are 3 different situations for the sodium chloride. These 3 different conditions are dilute, molten, and concentrated. So here we have the 3 different parts. We have the Okay, we have the concentrated NaCl, we have the dilute NaCl, and we have the molten NaCl. All the three different situations are there. We remember if there is just molten NaCl, you will have only one type of cations and one type of the anions. The only cations were sodium ions, and only anions were chloride ions. So they were the only species that were discharged at the respective electrode if we used only the molten form. But if we use the dilute NaCl, it used to have more amount of the hydrogen ions as compared to the sodium ions, and more amount of the hydroxide ions coming from the water as compared to the Cl negative ions. And when we had the concentrated form, again, concentrated would have more amount of the Na ion as compared to the hydrogen ions, and more amount of the chloride ions as compared to the hydroxide ion. Cl minus were greater in amount than hydroxide ion. So we are supposed to look for the products for the concentrated aqueous NaCl. So concentrated NaCl will produce hydrogen. Why hydrogen even in the concentrated form, even though we nowadays more sodium as compared to hydrogen? The reason is that if we look at the reactivity series for sodium versus hydrogen, the series is over here. If we look at the difference between sodium ion and hydrogen ions, there is a quite large gap. There is a quite large difference between their positions. Sodium ion is much reactive as compared to the hydrogen ion. That's why sodium ion cannot be reduced at all. By reduce, we mean it cannot accept the electrons. It's not possible for the sodium. But hydrogen ion, on the other hand, is very less reactive, so it can easily accept the electrons to get reduced. So that's why we get the hydrogen gas produced in both the cases, in both the dilute form as well as in the concentrated form. Both cases will give you hydrogen gas. So hydrogen gas is produced at the cathode by the reduction of electrons, and on the anode side, there is more amount of the chloride ion as compared to the hydroxide ion. And according to their reactivity, chloride or halide ions have more ability to get reduced by gaining the electrons. So for this reason, we have the chlorine gas produced at the anode. The chlorine gas will be produced at the anode because of the reactivity of the chloride ion. They are more reactive, which means they can easily lose the electrons as compared to the hydroxide ions. So these are the products: hydrogen gas and chlorine gas. These are the products at the in the condition of aqueous sodium, concentrated sodium aqueous NaCl. So hydrogen gas and chlorine gas. So is the correct option. Then next question. Question number 14. Question 14 says, molten lead bromide is electrolyzed using the inert electrodes, which statement describes the movement of the electrons? Now, this is a generalized stuff, and here we must remember what the electrodes basically do and what their signs are. We remember that negative electrode indicates the cathode. It represents the cathode. The positive electrode represents the anode. And at cathode, there is gain of electrons for reduction. At anode, there is loss of electron for oxidation. If anode shows loss of electron, then there will be electrons produced at anode. That means electrons will coming out from the electrode in this way. They will be coming out. And cathode shows reduction by gain of electrons, which means the electrons are going towards the cathode. So they will be directed in this way. They will move into the electrode. Now, according to this, we will find the correct statement. Which statement describes movement electrons? So from X to Y through external Y, or from X to Y through electrolyte. So it is not through the electrolyte. So this is the electrolyte, which is the liquid portion. So electrons do not move through within the electrolyte. Instead, they move through the external Y. So the option A is the correct option. Then question number 15. In a fuel cell, a fuel is oxidized to produce electricity. Which row describes the fuel and oxidizing agent used? We did this question in the previous paper as well, related to the fuel cell. Now, if you remember, we said that fuel cell has simple reaction of hydrogen reacting with the oxygen to show the combustion. H2 plus O2 reacts together and they produce the H2O. This is a simple reaction in the fuel cell, and it also generates electricity. That's the purpose of the fuel cell. Now, for fuel cell to keep running, it has to provide the fuel. So fuel in this case is basically hydrogen. Hydrogen is a fuel. And oxidizing agent. You know that oxidizing agent means something which oxidizes the other substance. Oxidizes other. And here in this case it is O2. O2 is the oxidizing agent. Oxygen gas. So these two ticks in the option B. The next question. Which statement about reaction is correct? A reaction that is vigorous at room temperature has high activation energy. By vigorous, we remember it means a very fast reaction. A very fast reaction is called vigorous reaction. So to be a reaction to be very fast does not require high activation energy. It requires low activation energy. If we understand this from the energy profile diagram, we can understand it more easily. And for that purpose, I will open the notes related to the energetics or enthalpy. In this diagram, we remember activation energy is the difference from reactants level to the top of the peak. So if there is less amount of this peak value compared to the reactants value, then there will be less energy required by the reactants to pass through. Just like in exothermic, there is just smaller energy difference, but in case of the endothermic, there is a quite large energy difference. That's why we can say there will be slow reaction in case of endothermic, and there will be fast reaction in case of the exothermic or vigorous reaction because of the smaller value of the activation energy. By applying the same concept in our question, we say that very fast reaction does not require high activation energy, rather it requires low activation energy. So A is incorrect. Then B option says if delta H for a reaction is positive, bond making in the formation of the products is endothermic. We can easily be confused by these words. Delta H positive does mean it is endothermic reaction. It is correct. Delta H for endothermic reaction has a positive value. It's positive and it's endothermic. But the words are not correct here. It says delta H is positive, but it does not say the reaction is endothermic. It says bond making in the formation of products is endothermic. It should be bond breaking. Bond breaking should be endothermic. We should say this. That will give you the correct relation between endothermic, delta H positive, but not the bond making is endothermic here. So this is the wrong relation. So that's why B is incorrect. And it should be bond breaking in the breaking of the reactants. Bond breaking in the reactants, not in the products. That will give you the correct relation of endothermic time reactants. So that's a B is incorrect. Then C, in an exothermic reaction, the energy required to break bond is less than the energy required to energy released to make bonds. Now, if we need to justify this statement, just recall the formula which I explained you before. The simple and easiest way to represent delta H. It is bonds broken minus bonds formed. So simply consider the statement. It says energy required to break bonds is less. So that means the broken value will be less and the energy released during bond form will be higher. So its value would be higher. So as a result of this difference, the value of delta H will be negative. This value is smaller, this value is higher, so you get negative value. And negative value indicates the exothermic reaction. So this statement is correct by all the words. By all means, this is the correct statement. So C is the correct option. But even then, we will need to validate the last option D. It says reactions with a positive enthalpy change, that is endothermic, delta H is endo, and it means there is always transfer of thermal energy to the surroundings. So no, transferring the thermal energy to the surrounding is the indication of the exothermic reaction, not the endothermic. So they are opposite terms. So that's why D is wrong statement. Next question number 17. It's again a similar type of question in the previous variant, second variant. We just need to do the calculations. So first of all, we have to find the enthalpy change of the reaction, and same formula will be applied, which I have just mentioned over here. Delta H is equal to bonds broken minus formed. So apply the same formula here, and we know bonds broken are done for the reactants. So if you're breaking the bonds, you are doing this for the reactants, for reactants. So here in this case, the reactants are ethene and hydrogen molecules. So simply add the values. For ethene, we have a carbon-carbon double bond present, one bond of carbon-carbon double bond. So its value is 614. So add the value 614 plus there are four carbon and hydrogen bonds. There are four of these bonds. So multiply CH bond with 4 plus 410 in times 4. So this will be the value of ethene. And then we also have hydrogen molecule with the value 436. So 436 added. When you add them all, the value is equivalent to this value is equivalent to 2690. This is the value for reactant side, and then for the product side, there is one single bond. The value is 350. So on the product side, 350 plus the value of carbon to hydrogen. Again, use the same value, 410, but this time there are six bonds between carbon to hydrogen. So 410 times 6. And this is equivalent to 2810. Now take the difference for broken minus formed. Broken value is 2690 minus form value is 2810. So you get equivalent to minus 120. So in this way, P is a correct option. Then question number 18, zinc reacts with dilute hydrochloric acid. Which statement about the particles in the reaction is correct? A option, increasing the concentration of the dilute hydrochloric acid increases the collision rate, but no effect on the activation energy. So we know that it is the catalyst, which is affecting the activation energy. Activation energy is affected by the use of the catalyst. Neither the concentration nor the temperature affects the amount or the value of the activation energy. So yes, this is a correct relation that if you increase the concentration, there will be an increased amount of the collision rate, that is collision frequency. By rate, it means frequency. Collision frequency will be increased and it will not affect the activation energy. So in both ways, this is correct statement. So A is correct option. But even then, we validate the other three options. B says increasing the concentration of dilute hydrochloric acid increases the collision rate. So this is correct. And the activation energy, that is wrong. It does not increase the activation energy. It does not change the activation energy at all, neither increase nor decrease. C is increasing the temperature of the reaction increases the activation energy. So again, that's incorrect relation. It has no effect on the activation energy, but it only increases the collision frequency or the rate of the reaction. You can say collision frequency or you can say collision rate that is affected. In the D option, increasing the temperature of the reaction causes all collisions to lead to a reaction. So we remember that increase in temperature increases the collision frequency, but yeah, it also increases the kinetic energy. That is also increased. Kinetic energy of the particles is also increased. But we cannot say that it is wrong, but not all the collisions give the product. That word is incorrect. It just increases the rate of the reaction, but that does not mean all the collisions will be effective collisions to give the reaction or to give the product. So in this way, it is also incorrect. Then next question 19. Ethanol is manufactured by the addition of steam to ethene. The reaction conditions are 300 degrees centigrade and 60 atm. The forward reaction is exothermic. Which rows describe the effect on the equilibrium yield of ethanol when the state change is made? So we must relate the conditions required for the equilibrium reaction. If it is exothermic, then we remember the decrease in the temperature shifts the equilibrium towards the product side. Equilibrium shifts towards the product side. P stands for product. And we need to increase the yield of the ethanol, which is basically the product here. So decreasing temperature will be required. And adding catalyst. The addition of a catalyst has no effect on the position of equilibrium because it increases the rate of both forward and backward reaction. So catalyst has no effect. And third is decreasing the pressure. So by pressure, we have to look at the number of the moles of both the reactant and the product side. We have 1 mole on the product side, but two moles of the reactant side. So they are 2 moles. So if you decrease the pressure, if the pressure is decreased, then the equilibrium has to shift on that side where there are more moles. So the equilibrium will shift towards the reactant side by decreasing the pressure. So it is towards the reactant side, which is not correct for our increased amount of yield. So the third statement is also wrong. Decreasing the pressure shifts the equilibrium towards the reactant side. So it's only C option that is correct. That is the second statement that is correct. One more thing, yeah. Uh, I did mention no effect in the first statement. That is already written on the right side. No effect means no change. So it's correct statement already. No effect means no change. So first statement is also correct. Second statement is also correct. So first and second statements are correct, which means A is the correct option. Then next question, 20. Which rule defines the conditions used to make sulfur trioxide in the contact process? So if you remember the conditions for this reaction SO2 plus O2 to make the sulfur trioxide SO3, we do require vanadium pentoxide. This is used in contact process, and along with that, you should be very careful for selection of the pressure because Haber process requires this much value 20,000 kilopascal. This is for Haber process, and for contact process, this is the value 200 kilopascal. If you convert them into ATM, then this is 2 ATM, and 20,000 kilopascal is equal to 200 ATM. This is equal to 200 ATM. So be careful by selecting the pressure values. So this is correct from this part, and vanadium is also correct, which means B is the correct option. Question 21 is not related to our topic right now. Question 22, that's the last question. The equation shows the reaction between copper and concentrated nitric acid. Which elements reduce in this reaction? To find the reduction of the element, you need to specify the oxidation states of the element, especially other than hydrogen and oxygen. So other than hydrogen and oxygen are copper and nitrogen. So start with the oxidation states of these two elements only because that will save your time. Cu is in the elemental form, so zero state. Here, oxygen carries -2 charge for 3 atoms, that is equal to -6. Hydrogen will have +1 charge, which means nitrogen would carry +5 charge to make it 0. Overall charge should be 0. So nitrogen has +5. Here, nitrate ion is already there, just like this nitrate ion, so there will be no change of the nitrogen oxygen state here. But for copper, we should remember that nitrate ion overall charge has -1, and there are 2 atoms of nitrogen. There are 2 molecules of nitrogen, so that will give you -2. So to balance -2, the copper would have +2 here. So copper has +2. And then on this side, oxygen has -4 for 2 atoms, which means to balance it, nitrogen would have +4. So that's sufficient for you to identify because you do not need to check the oxidation state of oxygen and hydrogen. They are all same. So we can see copper changes from 0 to +5. That shows the oxidation. And nitrogen changes from +5 to +4. From +5 to +4. So this shows the reduction. So nitrogen is basically reduced. This nitrogen is reduced. This nitrogen has no effect because it is still in +5. So there's no change for this nitrogen, but there is a reduction for this nitrogen. So this was the last question of this paper related to our topics, which we are currently covering. In this way, we have completed the 3 paper 2 variants. So that's all for today, students. If you have any question, please let me know. All right, students, that was all for today. If you have any query, any question, and you may leave your comment, or you can reach me out on my WhatsApp number. In our next class, we'll be doing the paper 4 of the same series. That's all for today, students. Till our next class, take care and Allah Hafiz.